Hey guys, Brian here. Welcome back to the shop. I had a lot of comments in the last video about the spindle qualifications on this drill and whether or not it was screwed up from the drop and bent, or what was going on with it from that fancy setup I had, boring the hole with this boring bar in the chuck. People like that too. But that was the only thing I had that was grip a straight shank in this Morse taper. So that was how I adapted up. Obviously the adapter or the arbor on this 20 end's not very good. That's where the run out was coming from. Also, I went in here and found there is a screw clamp right here underneath of this plate. I took off that there's a dust seal in. So I took that down and went in there and tightened that up in order to get the spindle where it slides inside was where all the looseness was coming from that I was getting when I could push it and get that. I think it was 7 thousandths I was getting when I was pushing on it before, and I've cut that in half pretty easy. So, and it still moves okay. Nice and free. So let's take a look at this spindle and see what it got going on here. First off, in order to approximate a drill, I've got this Morse taper extension that I've put in an adapter that's in the spindle in order to put this in this drill. This is the straightest thing that I've got to do this with. I hope to be getting a spindle proving bar that I can use on this and also on the boring mill. Later on I may do some tweakage to try and get the spindle a little more true than what it is, but for right now I think it's actually pretty good. So let me get this indicator set up where you can see it, and let's take a look. Alright, so I've got my indicator here. Got it zeroed out, and you can see got about something around 2 thousandths. If I push on this, 200 pounds, I get probably half that. So that's pretty good and rigid. I'm going to drop down here on the spindle and let's check it at what would be a drill bit tip, essentially. So I'm actually getting not a lot different there, about 2 thousandths. That's at 8 inches away from the spindle. Let's check deflection down here. I can get about 2 down there. Of course, everything's cold right now. If this was warmed up some, it might be a little bit tighter. Okay, so I've now got this at half of the spindle stroke. So I'm about 12 inches out from the bearing. You can see it's pretty similar. Still getting around 2 to 3 tenths. So I'm going to go to the end of the bit here. Now about 19 Yeah. About 18.5 inches from the spindle bearing. So we're getting stuck out there pretty good now. They're still getting around 3. Do deflection test. And push about 4. Or pull it. It's all the way out. So I'm 22 inches out now. And I'm probably getting about 4. Let's go all the way to the end. Alright, so we're 32 inches out. And it's still probably somewhere around 4 or 5. So now, as a repeatability test, I want to knock a spindle, knock this adapter out, turn it 180, and check it again and see if my numbers vary. Turn 180. And reinsert. If anything, I actually get better there. I'm showing like 3/10, 3 thou. Yeah, showing about 3 thou all the way at the end of 30 inches. That's pretty good. So I'm getting 4 or 5 there now. Pretty typical. So this is at the spindle all the way out, 24 inches. Let's do a deflection test. At 30 inches, about 4 thou. That's not too bad for a 75-year-old machine, I don't think. So I've got the spindle back retracted with it turned 180 from where I started. Let's check the run out. It's like around 3. Do deflection. 2 probably. Back to that couple of 2 or 3 there again. So it looks like it repeats fairly good. It's fairly good, it's not too bad. 5 thou out or something. At most over 30 inches of spindle travel. that's pretty good probably. A lot of straight edges are angle blocks and stuff. The tolerance on them's a 1/2 thou per 6 inch, so a thousandth a foot. So means this is within, not quite as good as a angle block, but it's close. So the 5 thou over 6, but it could be better than that because it's hard to tell since it was getting 2 down there at the bottom when I turned it around. I don't know how good this piece is that I'm indicating off of. You know, there's some error in it apparently. When I had it in the lathe, I put it in there to check it before I tried to use it for this, and I was getting like 2 thou. I figured in the lathe that it's off maybe. So if I'm indicating that on the lathe of 2 thou and there's 2 thou here, it could be actually within the 3 thou tolerance or thereabouts over the entire travel. We'll just have to get a better spindle proving bar and check it and see. And like I said, maybe I'll try and do a little straightening on it if I need to get it tweaked in, but for now I think it's plenty good, especially for boring holes and drills. I mean, if you're 5 thou over a distance that long on a drill, that's pretty good, I think. I see a lot of little new drills that aren't that good. So if you've got one of these machines, or if you've got a big drill, you want to qualify it and see how it compares, I'd be glad to hear your results on it, how good your drill is. There was a lot about what the accuracy on this would be after it was dropped and crashed, and it's not too bad. Like I said, especially for a 75-year-old machine. So sub 3 thou, probably over 30 inches. So I'll take that. Heck, my Cincinnati, usually on the spindle on it, it'll indicate 1.5 thou a lot of times. Sometimes worse than that, depending on what NMTB tools I've got stuck in it. So I'll be getting that with this much stuck out of this. It's actually probably pretty good. Because like I said, I'm not actually at the spindle. I would get better than that there, I think. Well, let me go on this ground adapter and see what we get. At the spindle on the first adapter, I get it about 1 thou. With it this way, so let me knock it out and put it back in 180 and see what I get. So I only get about 1/2 thou now. Fired up, and let's take a look at the wobble across the range. Spindle 30 inches out. I think that looked pretty good over the full range of motion. So probably not as good as a new Harbor Freight drill press would be, but I think it's good enough for this shop for what I'm gonna do with it. So I'm pretty happy with how it's looking. And like I said, if I get a better proving bar or something where I can do a more accurate test on it, I'll certainly do that. And then if it's out, maybe I'll see about tuning it up, or maybe I'll see about tuning it up a little more anyway, just for the heck of it, because it's always fun to chase after precision. So even for cutting holes, it's not necessarily a big deal. And you know, if it's actually got run out, it just means that your hole size is going to be off from what your nominal would be. So, but it still cuts a round hole. It just swings it out bigger diameter than what it's supposed to be. So, thanks for watching, thanks for subscribing, and I'll catch y'all later.